Hi and Assalamualaikum. We are from Group 12. We'll be presenting a final project utilizing GIS for a sustainable landscape planning solution. Klang is divided into North Klang and South Klang, which are separated by the Klang River that has become the main source of including attractions for people and tourists to visit due to its unique characteristic and identity. Klang is famous for its industrial and residential district. However, Klang frequently has to face major issues that involve both nature and physical structure in the city. We choose flash flood as an issue because it has become a hot and trendy issue that occurs around Kuala Lumpur and Selangor state. Klang is the one of the top cities that being involved in this issue. This is just bringing a few impacts towards the ecosystem and people that inhabit in the city. We identified the major problem in the Klang of flash flood issue is river pollution that causing flora, fauna, wildlife and aquatic life being harmed and hard for them to survive. Next is improper and inefficient water management. The flash flood has damaged human property such as cars, houses, documents and others. Lastly, improper sewage treatment, such as stagnant water that carries garbage in the area causes all the garbage to dump. So, for a better understanding about site conditions and analysis use, I will pass to the next presenter.
For GIS analysis, there are three parts of analysis that we use to analyze the data in Klang Selangor. First one is terrain mapping and analysis, which is dam, slope and thin analysis. Second is viewshed and watershed analysis. The last one is multi-pouring buffer and soil type permeability. Based on our case study about flood management at Klang Valley, flash flood becomes an annual problem, especially during the monsoon season because of various issues. So by using GIS in this project, there are three types that can use. Remote sensing is to detecting and monitoring the physical characteristics of an area. ArcMap is to display and explore GIS dataset in study area, and ArcScene is to navigate and interact with 3D perspective and raster data. So we can conclude that opportunities in using GIS is it allows to analyze and visualize different types of data and select an alternative solution for flash flood issues.
The first process that we use is thin analysis. Thin is a data structure that has ability to represent linear and point features. After the process, we can detect and accurately define the channel and floodplain area. Next is dam and 3D perspective. The purpose of dam analysis is to know the hidden area which is needed to create a map with a shade effect. By 3D perspective process, we can determine flood area more accurate using a texture map. Next is slope analysis. The purpose of slope analysis is to know which area has high, moderate or low potential of flooding based on slope elevation. For viewshed and watershed analysis, we can determine the area view that could be seen from particular location and detect the watershed area which is a potential flood area. For soil permeability analysis, we can determine the level of water absorption into several types of soil in certain areas. This process, we can prevent future development at high-risk flood area.
Next is forest buffer analysis. The data that we use is forest data and district data. The buffer is generated around the existing forest using distance parameter which is 2 km, 6 km and 25 km that used to identify the flooding area. Next is result of all analysis. From all analysis, we come up with final map which is sensitivity map. From the sensitivity map, we can conclude that the area with red color indicate high sensitivity area that more vulnerable to water surge and flash flood. As you can see, the red color on slope raster map show the flooding area. On elevation raster map show area that close to the river. On soil raster map show the low soil permeability, and for the forest buffer raster map show the area that far from the forest.
For discussion in group, we have identified a few problems during the analysis part. As you can see, for the example, the tin does not fit the coordinate properly in the middle of the process. So, the solution is we need to edit the tin by inserting boundaries as the input features. By using these GIS analysis tools, it helps us to give a head-ups on flood control where we can integrate bioretention pond, or implementing flood warning system, which helps to alert the community nearby, especially in the area of Kapar, Meru and Bukit Raja in Klang. The other suggestions to cater this flood mitigation are installing sustainable retaining wall, infiltration of rain garden, and last but not least, stormwater management. As a conclusion, we are able to get more input on how to identify the best planning solution by using GIS tools in our final project.